Today, we're going to talk about how to find different types of angles involved with circles. So we're going to take some notes, then you'll do a little picture scavenger hunt with your phone, and then we'll finish up our notes, and then we'll play a really quick Kahoot, and then we'll practice these concepts on your own, and then you'll take your exit ticket. So our goal today is to find central and inscribed angles if I give you the arc, and then also to work backwards. Remember, this is the SAT formula sheet, and on the SAT formula sheet, they talk about circles a little bit, how to find the area and how to find the circumference, a 3D circle, a sphere, how to find the volume of it, and then they say the number of degrees of arc in a circle is 360. So that's the thing we're going to use today is the 360. If you can title your notes, Angles of Circles. And the first thing I want to go over is how do you name circles? So remember, you name it based on whatever we label the center point. So if I label the center point Q, this is called circle Q. This dashed line right here from Q to S that connects the center to the circumference or the edge of the circle is called the radius. Remember, a circle has an infinite number of radiuses, radii, and they're all the same length. So if I have two different radiuses here, they create an angle, and this angle that's connected to the center of the circle is called the central angle. Now this other part, the curvy part that connects R and S, that curvy part is called an arc. An arc is a curve bound by 2 points. So some fun facts. The central angle, if I measure it in degrees, it's going to be the same measurement as the opening of the arc. So my angle QRS is the same measurement as arc RS. And one thing I didn't put on here is that we have to put a curve, an arc on top of arc RS. So you know I'm talking about the curvy part, not the straight connecting part, which is called a chord, and we'll talk about that next lesson. So if my central angle is 100 degrees, that means this arc RS is open 100 degrees. So they're the same measurement. Remember that all central angles, all the angles, all the arcs in a circle, it's all going to add up to 360. And so there's two ways I can go about this circle. I can go from RS. I can go from R to S this way, or I can go from R to S the longer way. And so another fun fact about this is that if you have the same two endpoints, R and S, there's multiple arcs. There's the major arc, which is the larger one, the larger path, and the minor arc, which is the smaller path. So when I look at this 100 degrees, you got to think, for this RS, is this the smaller one or the larger one? Hopefully you know 100, it just looks smaller than the other way around. So that means arc RS is 100 degrees, minor arc RS is 100 degrees. If I went the other way, remembering that they all add up to 360, if I take away 360 from, or 100 from 360, I get 260 degrees. So my major arc is 260 degrees. Again, you got to put a curve on top of it. If they don't say major or minor, they always mean minor, the fastest method. Okay, so pop quiz time. What is x? Well, x is a central angle. It's touching the center of the circle. So it's going to be the same as the arc it intercepts, so it's 62 degrees. What is x? Again, x is a central angle, and so it's going to be the same as the arc it intercepts, so it's 140 degrees. Here, what is x? X is another arc, not an angle. And I know they all add up to 360, so if I take 360 and I subtract 140, I'm going to get 220. So x is 220 degrees. Okay, here I have, let's assume it goes through the very center. This central angle, it's a straight line. That means it's 180 degrees, or it's half a circle, half of 360. Now here, again, a straight line's 180, so if I take away 45 degrees. I'm going to get what's left over. So that's 135 degrees. Imagine that was a 3, not a 7 looking number. Okay, so that's all about central angles. Okay, let's draw the same circle, circle Q with points R and S on the circle. But this time, instead of drawing the radius, I'm going to draw two little line segments that connect from R to T and T to S. So I have a different angle. These segments that have endpoints on the circle, they're called chords. We'll talk about it more next lesson. Okay, so angle T. If I look at angle T, again, I'm going to assume this RS is the same as this arc RS. If you just think about it, hopefully you understand that angle T has a smaller opening, or it's a smaller angle than this angle Q right here. This one's bigger, so hopefully you understand that angle T is going to be less than angle Q, so it's going to be less than 100 degrees. And our fun fact is that this angle that's touching the circle, it's called the inscribed angle. Our fun fact is that the inscribed angle is always going to be half of the arc measure, or half of the central angle if I had drawn the central angle here. So if my arc measure was 100, my inscribed angle has to be 50. So if I wanted to draw my central angle in the same picture, this one would be 100 because the central angle and the arc are the same measure, and then the inscribed angle is half of that. Okay, sorry. So pop quiz. What is x? X is a central angle, so it's the same, so it better be 48. Here, x is now an inscribed angle, still intercepting the arc of 48, so it's going to be half of 48, so it's going to be 24 degrees. Okay, so if I'm going this way, I half it. To go the other way, I'm going to double it. So when I double 30 degrees, my arc is going to be 60 degrees. Okay, this is also an inscribed angle. It looks scary. It's just its vertex is on the circle. This is the intercepted arc. So I'm going to double it. So my arc is going to be 200 degrees. Okay, again, the inscribed angle is half of the intercepted arc, so it's going to be 110 degrees. Okay, this one looks scary. So I have my circle divided into 220 degrees and whatever's left over. Remember, they add up to 360. So if I take away 220, I get 140. So x is 140 degrees. Okay, so you're going to do a little scavenger hunt. You're going to take 4 pictures on your phone, and then on 2 of them, you're going to draw and label. Give me an example of 2 different circles, one where the central angle and the arc measure are labeled, and make up a number for them, a realistic number, and then label the inscribed angle and the central angle. Just draw an angle on top, and then make a measure up. And then you're going to take 2 other easier photos. You're just going to review what congruent circles look like and what similar circles look like, and just label them. Okay, so after you've done that, let's finish up our notes. So our next vocabulary word is an inside angle. Sorry, my animations were off a little bit. So here I have an angle. Remember the pointy part's the angle. I have an angle made by these 2 little dashed lines I have going on. We'll talk about what they're called. They're called secants. But these 2 little dashed lines, they intersect inside the circle. So previously we had the central angle, which intersected at the center, and then we had an inscribed angle, which meant the angle was touching the circle. And this is our third case, which is an inside angle. Okay, so our fun fact is that our inside angle, inside angle is going to intercept or touch the circle and form 2 arcs. So if I'm focusing on this angle, if I were to continue the lines, just continue them up, I get this arc. Now, remember this orange looking angle, it has its vertical angle buddy right here. They're the same measurement. So if I continue them, they intercept this arc. So my inside angle intercepts 2 arcs. So how do you find the measure of the inside angle? What you're going to do is you're going to add the 2 arcs and then divide them by 2. So basically you're going to average the 2 arcs. So my inside angle equals 1/2 arc plus arc. So let's do a really quick example. What I did is I just labeled 68 degrees, x degrees, and 20 degrees. Remember, the angle is the pointy part, so x is my angle. It's going to go right here, x equals 1/2, and the arcs are the curvy parts. So make sure you plug it into the formula correctly. Systems of equations, I'm going to do my parentheses, my grouping together, so 68 plus 20 is 88, and then I'm going to take half of it, so x equals 44. Easy peasy, right? Sometimes the questions are going to give you, they're going to reverse, so you're not solving for the angle. So I just redrew the same picture, and I'm going to act like I knew that x was 44, but I didn't know that that was 68, so I just put my x there instead. So when you're plugging it into the formula, make sure you say your angle equals, they're all degrees, so make sure your angle equals 1/2 arc plus arc. So again, our angle, that's the pointy part. So 44 equals 1/2 x plus 20, or 1/2 20 plus x. So now that I've set it up, there's a couple of ways to solve it. I know y'all like to get rid of the fractions, so I'm going to multiply both sides by 2 to get rid of that 1/2. That gets me 88 on the left. And then the fraction goes away on the right. And then we'll subtract 20, so 68 equals x. Okay, so pop quiz. What is x? So again, it's the angle, the pointy part, equals 1/2 of the 2 arcs that it intercepts. So if it helps you, continue the lines out. Continue the lines out. So it's going to be 1/2 80 plus 20. Okay, order of operations, do the parentheses first. 80 plus 20 is 100, and half of 100 is 50. I like to draw the lines out because sometimes they might give you these other numbers. I'm just totally making this up, but like it might label this other arc. So don't just add any 2 numbers. It has to be when you extend that angle out. Okay, next question. Again, the angle, x equals 1/2, and then the arc it intercepts, and then the arc its vertical angle intercepts. So 70 plus 20. Order of operations, 70 plus 20 is 90. Half of 90 is 45. Okay, here we go. So I have x right here. So again, x is the pointy part, so x is my angle. It's going to equal 1/2. And then I continue. So that's going to be half of 100 plus, and this is also x because they're vertical angles. So 100 plus 120, so half of 220, which is 110. Okay, here we go. We got another problem. Oh, but here the angle, the pointy part, is 100. So it's going to be 100 equals 1/2 of my 2 arcs. So the 2 intercepted arcs are x plus 120. Now, how do you solve this? I like to get rid of the fraction, so I'm going to multiply both sides by 2. So I get 200 equals x plus 120. And then subtract 120, so I get 80 is my x. Okay, here again, my pointy part is 40. So my inside angle equals half of my 2 arcs added together. So x and 30, x plus 30. And then now that I've set it up, I'm going to solve it. Multiply both sides by 2. I get 80 equals x plus 30. Subtract 30. And I get 50 is my angle. Okay, let's do 2 last examples, 2 last types. So in our notes, draw yourself a picture of a circle Q, but this time my 2 little lines, they're going to intersect on the outside of the circle. So I'm just going to call this an outside angle. So it's where the pointy part, the vertex of the angle is on the outside. Okay, so if it was on the inside, we added the arcs and divided by 2. So if it's on the outside, if I were to continue my angle, it intercepts two arcs again. And what I'm going to do is I'm going to subtract them and then half up. So half of arc minus arc. Okay, so let's do an example problem. Here I have 80, 20, and x. You need to start by understanding what your angle is. Remember, the angle is the pointy part, the arcs are the curved parts. So my angle is x, and then I have two arcs, and it actually does matter what order you put them in. Make sure you put the bigger number or the bigger arc first, and the smaller one second. So my bigger one, it just looks bigger, 80. I'm going to do 80 minus 20. Okay, order of operations, do the parentheses first, then half it, so x equals 30. So let's do a similar problem. Let's just act like, for our last problem for today, let's act like I knew that my angle was 30, but I didn't know this other arc was 80. So I just drew the same picture, same numbers. I just put an x here. So your angle, that's the pointy part. So that's my angle, that's going to go there. And then my two arcs are the curvy parts, so x and 20. Again, the first arc has to be the big one. Otherwise, you'll get a negative answer. So it's going to be x minus 20, not 20 minus x. How do you solve it? Multiply both sides by 2 to get rid of that fraction. And then add 20 to both sides. So x equals 80, which is just what we wanted. Okay, so let's do a pop quiz. It's on the outside, so that means my angle, x, is going to equal half of arc minus arc. Which one's bigger? Well, hopefully you understand that 120 is bigger than 40. So plug it in. Combine like terms, so 120 minus 40 is 80. Half of 80 is 40, so x equals 40. Okay, here's another one. Again, my angle's on the outside, angle's the pointy part. So my angle equals 1/2 of arc minus arc. Again, that's the big one, so 120 minus x. Sorry, my handwriting's not the best. Multiply both sides by 2, so I get 80 equals 120 minus x. If I subtract 120, I get negative 40 equals negative x, so that means x equals 40, because you multiply both sides by a negative. So 40 equals x. Okay, we're going to play a quick Kahoot on this vocabulary. If you can get out your devices and play that if you're in class. And then when you're done, we're going to work on this little half-sheet worksheet of some problems. And then there are 4 Khan Academies for today. And then we'll do our exit ticket. And that's it.